Hello and welcome to the Open Systems Media Embedded Solutions video, where we are covering the technologies that are associated with smart door locks that fit into smart homes and things like that. This event is sponsored by Infineon. My name is Rich Nass, and I'm just helping out here. I'm sort of moderating the talk. I'm also the Executive Vice President of Open Systems Media. I lead the content team for embedded computing design, a great resource for anything related to the design of hardware and software for embedded systems. So as I said, on this video, we will be talking about smart door lock design and how it fits into things like Matter and low power and with Wi-Fi and all that other stuff. My guest here is Declan Starr. He is the Director of Applications Marketing for Smart Homes, Health, and Lifestyle Applications at Infineon. How you doing, Declan?
Hey, Rich. How you doing?
Good. Thank you very much. So let me just explain what the format is for our audience. In a second, I'm going to step aside and I'm going to let Declan walk through a series of slides where he'll be discussing the evolution of the smart door lock and basically how you build one of these things today. And you'll find that it's not nearly as hard as I thought it was. At least we'll see what you think when we're done. And then if I think that there's something that needs more clarification, I'll interrupt him, and then otherwise I'll just let him run through, and I'll probably ask him some questions at the end. So
Cool.
with that, all yours, Declan. Take it away.
Well, thanks very much, Rich. Yeah, I'm going to take you through a few slides talking about smart door lock solutions from Infineon. So first of all, let's do a quick intro. What are we talking about here? So smart door lock is typically an application that includes connectable devices that can be used to control access to specific areas without the need for a physical key. And that's the important part, right? Without the need for a physical key. The overall application itself can be broken down broadly into a few different segments. The one we're going to focus on today is kind of the residential smart lock. So this is like the connected evolution of the traditional residential door lock. So it's all about providing secure access. Like, what's more secure than the front door of your home, and then also offering a level of convenience, right? People now in today's world with automobiles, right? They're used to, you walk up to your car and the door senses you coming and it opens, and people want that exact same experience with their home access. And so it's all about providing, secure access to convenience. The ability to have virtual keys to be able to let, people into your home, be it your home, be it a vacation rental, etc. But then also in the future, identification. So as you walk up to the door, there's a camera. It recognizes it's you, or it's your son, or it's your kids, and you get a text message saying, "Hey, yeah, your kids came home from school, got home safely." And then the most important thing about the residential smart lock is that it's battery powered. So basically, being able to offer solutions to this application that enhances and extends the battery life is crucial. And we're gonna focus on residential smart lock today. But the other segments in that cover in the application, and we'd love to come back at some point to discuss in more details, is, of course, commercial smart lock, what you have typically in your home or in your office. And the big differentiator here is it's typically more security focused. It's wired connectivity. There's a lot of tracking going on for safety and first responders, but in general, it's mains powered. So low power solution here is not the prime focus. And then an interesting trend we see is also with electronic padlock, the kind of evolution of the classic padlock. And Infineon offers some pretty innovative solutions here. Not requiring any battery in this particular device, being able to power that padlock from, let's say, NFC in your phone. And then the kind of, I always call them the adjacent segments. So other smart access applications that we see that are bubbling up, such as smart delivery, smart locker, safes, and furniture. So as I said, today we'll focus on the residential smart lock and why smart lock? Why do we care about this as an application? Because you can see basically on the left here that it's a fast growing market. So, in 5 years, you're going to see the amount of both residential, commercial, and padlocks. They're going to double over that time. And you can see from the regional split that it's pretty even, right? In Asia Pacific and Japan, America and Greater China are slightly ahead, whereas Europe is catching up. And we see that for many different reasons, right? There's a big global trend towards people moving from the country into cities, and with that comes a lot of and also offices and factories have all now become smart, accessible, right? But then if we go back and now we look at a typical system block diagram of a residential smart lock, right? Today, it's relatively simple, right? I'm just showing here on the left a split between, what's typically what I call what's in the door front or what's in the door back. Oftentimes in a residential smart lock, on the front you might have some keypad or some buttons or some LEDs or some buzzers so the human can interact with the lock in some cases. And typically, of course, the mobile phone is the main virtual key. And then on the door back, on the inside of the door, that's typically where you have all the electronics, because it's safe. It's on the safe side of the door. It's in the home, and that typically here in the red, it's typically some form of low power MCU. It can, in most cases, a connected MCU, and BLE is quite typically, because, as I said, the smartphone is the main digital key. Of course, there's, as I said, it's battery powered, so there's that aspect to become, and then there's a half bridge motor which is responsible for driving the deadbolt, and then of course you need some form of position sensor to determine whether the door is open, closed, did you lock it but the door was left ajar. So a lot of sensing goes on to make sure that when we say the door is locked, that we can confirm that it's actually locked. And then in this generation of smart lock, we also see some shape or form it gets connected to the cloud. And in the first generations of smart locks, that was typically through some form of bridging device that maybe spoke BLE and then went Wi-Fi to the cloud. And a trend that we're seeing right now is that the smart lock manufacturers have started integrating the Wi-Fi into the actual lock itself, and we'll come to that in a second. But the problem is that complexity is increasing, right? As I said, there's autonomous lock and unlock. People want the door to perform the same as their door in their home, to perform the same as their car. Then there's also presence detection. So they want to be able to detect, hey, somebody came towards the door. Did they drop off a package, and get notified of that? Then there's also personalization. They want to be able to know who came to the door. Was it my kids? Was it my neighbor? Was it the mailman? And then basically for some AI ML to be running in the background to give you that quick update. Then stuff like acoustic event detection. If someone's banging on the door or someone's trying to force entry, you also want to be aware of that and form some sort of an alarm. And then kind of what I showed, the big cog here is interoperability, is different smart homes. Up to this point, all of the smart home manufacturers have sort of said, okay, this works with Apple, or this works with Amazon, or this works with Google, right? Which meant that you had to be very careful about, selecting your smart lock depending on what your ecosystem was, what your phone ecosystem was. Oftentimes, the parents might be on one particular ecosystem, and the kids maybe phones are a little bit are different. So they're not all people in the family could have access to the door. So that's one thing to keep in mind. It's simple today, but it's becoming more and more complex. So it means that there's more and more. What Infineon is trying to do is basically create easy to use reference platforms around smart lock that just make it simple to integrate these solutions into your end product. And one example of where we've been successful has been with the PSOC 6 BLE device. So what I'm showing here is another variation of that smart lock. You can see here it has a fingerprint module. It's talking NFC. It needs some form of MCU to, like an CN0 type MCU to do the actual application. It needs a real-time clock because to be aware of time. In most cases, it has some sort of an audio chip or a voice chip where it can make a noise if the door opens, or it can have a kind of an intercom system to talk to the person at the door. some form of keypad. So if if you forget your phone, you can always type in a numeric key, and then in some cases a screen. And then, as I said in the past, it's generally a BLE device. And the beauty of PSOC 6 BLE was it was possible to integrate all of these inside of this dashed box into a single solution. So you basically ended up with, you can integrate the fingerprint matcher, the main controller, the real-time clock, and the capacitive keypad, BLE, voice IC, and secure element all into a single MCU, or connected MCU. And then it had a high performance. It was dual core, an M0 to handle a secure M0 to handle the actual locking of the moving of the motor for the lock. But then it had an M4 which could do all of the sensor, all of the sensor hub features like fingerprint sensing, such that you'd end up getting a fingerprint match within less than 200 milliseconds. And all while being very low power. So, running power of, in this case, of 44 microns per megahertz and 35 microns with the BLE advertising. And then, as I said, another area, now we've just seen with the PSOC 6 BLE for the first generation of locks, how we used the feature, the PSOC 6 low power features and all of that integration. But then, as I said, the next generation of trends is the integration of the Wi-Fi into the lock itself. And here's an example of a very successful platform design win we had with August Home, where we integrated we replaced that BLE device with the CYW 43012, which is a Bluetooth Wi-Fi combo device. And what were their asks from? What were their design challenges and requirements? Of course, they wanted always on dual band Wi-Fi. They wanted to be able to simultaneously advertise so that you could. This was a lock that was made to be Apple compatible. And then they wanted a secure micro that could secure micro where you could handle the lock and unlock operation, but then that was physically isolated from the M4, the sensor hub that would be doing all of the the sensor integration. Their desire was like 8+ months battery life with 10 locked activations a day. And the whole idea was this is a very small form factor lock, so they were trying to minimize BOM and board space. And then why did we win? Basically, this device, the CYW 43012, is the lowest power Wi-Fi 5 chip on the market today. It's been has a great success in locks, in IP cameras, at all of the major brands, and also with a lot of wearables customers. So the PSOC 6 is a dual core device. It has a secure core with a high performing M4 to do all the sensor hub stuff. And then basically we increased or extended the battery life by using some of our know-how in connectivity to enable system level offloads on the Wi-Fi Bluetooth. So allowing the Wi-Fi Bluetooth chip, even though it's an IC, allowing it to do some decode of Wi-Fi packets, so that it can leave the rest of the system asleep until that the message coming from the router is actually for the door lock.
Are there any tricks you can think of to further reduce that power?
Yeah, basically, if you think about a door lock, Rich, the two biggest, if you do Pareto analysis of the two biggest energy users in the door, the motor is one, and typically the connectivity is the second. So for motor, there's definitely there's some innovative solutions you could use with some innovative sensing around figuring out what they call the throw. So how far does that door, the bolt, need to move for it to be securely locked? So you could think about installing your door lock at the start and then running some sort of calibration sequence which basically measures the depth of that, so it minimizes, it knows exactly how far it needs to move that deadbolt to be a secure lock and unlock position. That would be the first thing. And then the second aspect is connectivity is the second biggest power consumer. So we've later this year, the big brother of this 43012 because these locks, these types of smart home devices spend 99% of their time sleep mode, waiting for somebody to come and use them. So what we've done is we've basically minimized the sleep retention, the sleep current in these devices to basically to double again the battery life of the smart lock by really examining, what we keep alive, what is active during these sleep modes, but at the same time allowing the lock to wake up in a fast enough time to respond to an asynchronous access.
Is it dependent on the situation in the home as well, how far you are from the router and things like that, how thick your walls are?
Correct. Yeah, that's you'll see here that the lock has both 2.4 and 5 gigahertz bands. So traditionally people used 2.4 gigahertz because it had better distance, better range, but we have a lot of features built into this 43012 device, such as beamforming, where it's able to operate on 5 gigahertz band, which would give lower range, but the fact that we can use beamforming to gain back that, and then you basically can be on air, send a message, and get off as soon as. So you getting back to sleep as quickly as possible is one key to extending the battery life.
Very good, thank you.
So we've just shown two solutions from Infineon that have centered around low power, ultra low power system solutions for the MCU, for the CapSense, for the connectivity. But that's only one kind of, one feather in our hat with respect to value prop that we have around smart lock. We also have, as I said earlier, the NFC energy harvesting. We have a solution, for electronic padlock where you can harvest the energy from the phone that you're using to open. So your phone has quite a beefy battery. You can harvest the energy from the phone to do the lock and unlock. That could be an emergency use case in case you come back home or you have a vacation rental and you go there and suddenly the batteries are drained. So allow you to do a one-time use or to do a supplemental use where you can pull some of that energy from the smartphone battery. But then also there's, we talked about the Wi-Fi 5 solution in the previous design win, but we're just launching our new Wi-Fi 6 and Wi-Fi 6E products, and we have some of these will be kind of connected MCUs. So they would allow you to both do the connectivity and integrate the application level onto a single chip. So again, reducing cost, making hopefully reducing complexity and improving time to market. Then Matter, as I said, Matter is another one. Matter is this, we're trying to come up with solutions that allow you, the user, to select the smart lock and the ecosystem that you want to use in your smart home. Infineon is a leader in Matter. We have a representative on the board. We have launched our Matter over Wi-Fi solutions last November with the official launch of Matter, and we have an integrated code example specifically targeted at smart lock built into our Modus Toolbox IDE. Then also, we have an advanced sensing and higher integration. So you talked about knowing, when to wake up. So if you keep this thing asleep for as long as possible. So if you've got, people have used PIR and other methods to wake up, smart home devices. But the problem with that is that, there's many different false triggers. And then every time these devices are waking up, like a smart lock, you really want some advanced sensing. So we have, different radar sensors, time of flight sensors to really understand and only waking up when there is someone, basically coming towards the door and getting the door ready to accept a qualified access, as opposed to a PIR where your neighbor's cat walks in front of the door or somebody's walking down the street and that also wakes it up, right? Which is a complete drain on the battery life. And then, of course, security. Security is a major feature. Infineon is one of the leading secure solution companies in the world, right? With over 50% of every credit card that you have in your wallet has a secure solution from Infineon. Same with the e-passports. So security is something that Infineon takes very importantly. And then, as I said before, what's more important than the security of your home with your smart access solutions? Understanding that up to this point, some of the smart lock technologies have been relatively straightforward, and now knowing that there's more, there's Face ID coming, there's UWB coming, it's getting more and more complex, more and more difficult to integrate. And it's a very fragmented market. There's a couple of big players, but it's quite a fragmented market. So Infineon has developed a smart lock reference platform, and this slide is just showing incorporating some of where we've won in the past with our low power processing with the PSOC 6 and the low power connectivity with the 43012, but then also bringing in the human machine interface with the PSOC 4 CapSense for the keypad. There's a lot of different memory solutions, be like non-volatile or NOR flash. Also, we have device protection on ESD authentication. Where ESD protection, we've also seen battery authentication becoming a real trend, where people are now adding cameras, they're adding more and more electronics that drains the battery. So to ensure the customer gets their required 8 months or a year, they're offering authentic moving from alkaline to lithium ion battery packs, and then ensuring the only way they can ensure it's like in a system, from a system view, is to ensure they know where the battery is coming from, and that it's an authentic battery from their manufactured by themselves, so they can guarantee the battery life over the life cycle of the lock.
Is this the actual reference platform that somebody would get from Infineon?
Yeah, what I'm showing here as the miniature lock is an actual demo version, but here on the bottom left is the actual reference platform. So it's basically these three PCBs that are shown here are what's physically inside of this lock. And the beauty with the reference platform is, hey, we understand everybody may have their own lock, they may have their own motor, they may have their own half bridge, so we make it easy for you to basically swap in and out what you're playing with. And we, as part of this reference platform, we give you with system power being like one of the key requirements, we give you a power calculator. So we give you a power calculator for all the Infineon stuff, but then make it easy for you to plug in and out if you have a different lock or you've got a different MCU. So you can get a good understanding of your overall system power. Your overall system power for your solution.
Very good.
Yeah, so it's all about making it easy for the customer. Hopefully, improving time to market. We're not trying to sell you a chipset. We're trying to sell you solutions, right? We're trying to hopefully make our customers integrators of Infineon solutions, so that it's not here, buy this chip from us, and we give you some code examples and off you go. No, we'll provide you with a fully integrated smart lock reference platform that in this case has CapSense as a wake up source. So when your hand comes close to type in the keypad, it wakes the whole thing up. It's integrated with the NFC reader. So we're trying to have done a lot of complex system level integrations here to hopefully make it easy for the customers to get time to market, all while being secure, by being low power, and being heavily integrated.
Speaking of making it easier, where would somebody go for more information?
Yeah, for more information, you can go to Infineon.com /Matter, and you'll come to the Matter promo page, and you'll find information on this solution and other solutions from Infineon. And also, if you do a search for smart door lock on the Infineon.com website, you'll also come to the same web page and information on this reference platform.
Very good. Thank you very much, Declan. This was very informative.
Rich, thank you very much for having me. Always good to talk to you.
That was Declan Starr. He is the Director of Applications Marketing for Smart Home healthcare lifestyle applications with Infineon.